Picture this. A palm-sized rover zips across your desk, a self-driving explorer you built from scratch. It glides forward, its single ultrasonic eye scanning the path ahead. Suddenly, it taps the brakes, stopping just an inch from your latte. It pauses for a second, chirps once like it's proud of itself, then pivots and glides left, continuing its mission. This isn't some $1,000 kit. This is yours for about the price of a large pizza. Give me 1 minute, and you'll see exactly how I knocked this little guy together. Give me 10 more, and I promise you'll be building your own. Hey there! A couple of months ago, I still thought Arduino was a fancy shape of pasta. I was convinced robotics required a PhD and a workshop full of soldering irons and 3D printers. Then I built this. 3 wheels, 2 motors, and 1 ultrasonic eye that gives it a sense of the world. There's no soldering, no complex schematics, and definitely no advanced degree needed. Seriously, if you've ever charged a phone or assembled a piece of IKEA furniture, you are massively overqualified. The complete parts list is waiting for you in the description below. Go ahead and pause here, grab that list, and hit play when you're ready to roll. Let's dump the kit out on your desk. You should have a small mountain of cool-looking electronics. Let's do a quick roll call. First, the blue board is your Arduino Uno knockoff. This is the brain of the operation. That other board that looks like a hat for the Arduino is the L293D motor shield. Think of it as the robot's nervous system. It takes commands from the brain and translates them into movement for the muscles, the 2 yellow DC motors. You'll also see a plastic bag with a snap-together frame, a small swiveling caster wheel for the front, a battery pack for 4 AA batteries, and a little blue gizmo with 2 silver cylinders that look like eyes. That's your HCSR04 ultrasonic sensor. To connect everything, you'll have a fistful of colorful jumper wires. That's the whole guest list. Spread them out like Legos. Your first step as a robot builder starts now. This part is pure mechanical fun. Grab the plastic base and the 2 side rails. They should snap right in with a satisfying click. Now take your 2 yellow motors. You'll notice 2 little wires, a red and a black one. Slide the motors onto the posts at the back of the chassis. A good rule of thumb is to make sure the red wires both face outwards, away from the center. It's not a deal breaker if you mix them up, but it keeps things tidy. Flip the base over. See that single slot at the front? Pop the plastic caster wheel in there. It gives the bot its 3rd point of contact, making it a stable little tricycle. Finally, grab the 2 rubber wheels and mash them onto the motor axles until they seat firmly. And just like that, you have a rolling chassis. Ta-da! Tricycle mode achieved. Time to give this thing a mind. Take the L293D motor shield and carefully plug it onto the Arduino Uno. The pins are designed to fit only one way, so line them up and press down gently but firmly. Now, use the small plastic standoffs to lock the Uno onto the robot's upper deck. Next up is the wiring, and it's simpler than you think. The shield handles most of the complexity, but we need to connect the motors to the shield. You'll see green screw terminals labeled M1 and M2. Grab 4 male-to-female jumper wires. Connect the wires from your left motor to the M1 terminal, red wire to the plus side, black to the minus. Do the same for the right motor, connecting its wires to the M2 terminal. That's all the motor wiring. Now for power, clip the battery pack's red wire into the shield's power terminal labeled VIN and the black wire to GND. See that little plastic jumper labeled X_V? Leave it alone. Removing it tells the shield to keep the motor power and the Arduino power separate, which is exactly what we want for a stable robot. Trust me, our robot needs to see. That's where the HCSR04 ultrasonic sensor comes in. It works just like a bat's echolocation. One cylinder sends out a high-frequency sound pulse, and the other listens for the echo to bounce off an object. By timing how long the echo takes to return, the robot knows how far away something is. The sensor has 4 pins: VCC for power, GND for ground, trig to send the sound, and echo to listen for its return. Stick the sensor onto the mini breadboard, then slap the breadboard right onto the front bumper of the chassis. Now for the jumper map, VCC goes to the 5V pin on the shield. GND connects to any GND pin. Trig goes to digital pin 7, and echo connects to digital pin 8. Blink twice, your robot sensor is now live. Hardware is done. Let's give it a soul. Open the Arduino IDE software on your computer. Plug the Arduino into your computer with the USB cable. Under the Tools menu, make sure your board is set to Arduino Uno and the port is set to the correct COM port, like COM3 or COM4. Now, open the code file from the description and paste it into the IDE. You don't need to understand everything, but let's look at 3 numbers worth tweaking. First, distance threshold, which is set to 20 centimeters. This is the personal space bubble for your robot. You can make it more cautious or more brave by changing this. Second, turn delay, set to 500 milliseconds. This controls how long the robot turns when it avoids something. Finally, you might see pin numbers for the motors. The code is what translates your logic into real action. Hit the upload button. It's the arrow icon. When the little LED next to pin 13 on the Arduino flashes once, you're golden. The brain is programmed. This is the moment of truth. Don't just let it fly off your desk. Prop the bot up on a book or a box so the wheels can spin freely. A few LEDs should wink to life on the Arduino and the shield. The wheels should start whirling forward. Now, for the magic trick. Wave your hand in front of the sensor. The wheels should stop, spin in reverse for a moment, and then pivot to the right before moving forward again. You just taught a machine to have manners in about 30 lines of code. That feeling of, I made that, is amazing. Go on, rewind that moment twice. I won't judge. Things not going perfectly? Welcome to robotics. It's all part of the fun. Are the wheels going backward when they should go forward? Just swap the 2 wires for that motor in the M1 or M2 terminal. Is the robot acting blind and crashing into things? Your distance threshold might be too high for the surface, or your trig and echo wires might be swapped. Drop the distance to 15 centimeters and re-upload the code. Got a weird bug you can't squash? Drop it in the comments below. The community is fantastic, and I usually reply faster than pizza delivery. This basic rover is just the beginning. Think of it as your platform for adventure. Want to control it directly? Add a tiny HC05 Bluetooth module. Load up the second code sketch from the description. Grab a free Bluetooth controller app on your phone, and you can steer your robot with a virtual joystick. Want it to follow a path? Tape a QRE 1113 infrared sensor under the robot's belly. This sensor can tell the difference between black and white, so it can follow a line of black electrical tape on the floor. Dreaming of a robot arm? Swap the ultrasonic sensor for a micro servo, glue on a popsicle stick gripper, and you can program it to pick up small objects. Same base, brand new personality. Those little yellow motors get hungry. With a fresh set of 4 alkaline AA batteries, you'll probably get about 20 minutes of solid zoom time. If you swap those for decent rechargeables, you can push that closer to 35 minutes. If you notice your robot suddenly resetting or acting weird, especially during a turn, it means the motors are drawing too much power and causing the Arduino's voltage to dip. This is a classic rookie problem with a simple fix. Adding a 100 microfarad capacitor across the VIN and GND terminals on the shield acts like a tiny, super-fast battery backup, smoothing out those power dips. Alternatively, you can feed the shield a separate, beefier battery pack just for the motors. Either fix costs pocket change and makes your bot much more reliable. Once you start building, you'll run into the same few gremlins over and over. If your robot just spins in circles, it means your motors are fighting each other. One is trying to go forward while the other is going backward. Just reverse the wires for the misbehaving motor. Is the sensor value stuck at 0 or some other weird number? You almost certainly swapped the trig and echo pins. It happens to everyone. Is the upload button in the Arduino software grayed out? You either forgot to select a COM port under the Tools menu, or you still have the serial monitor window open. The computer can't talk to the Arduino on 2 channels at once. 90% of your headaches will be caused by those 3 simple things. I keep a sticky note on my bench to remind me. Ready for more? The fun of this platform is how easy it is to expand. Glue a second ultrasonic sensor onto the rear bumper. With a few more lines of code, you can give your robot 360-degree obstacle avoidance. For a speed boost, try swapping the plastic frame for a lighter one made from foam board or even cardboard. Less weight means faster acceleration. Want to show off? pop on a tiny OLED screen and display the distance reading from the sensor like a mini dashboard. Every single add-on teaches you a new superpower, from data displays to advanced navigation. Pick one to try tonight and film it tomorrow. Think about what you just did. You took a grocery bag of plastic and silicon parts and turned it into a self-driving robot, all in the time it takes to microwave a big bag of popcorn. You've wired it, you've programmed it, and you've brought it to life. Now switch it off, juice up the batteries, then find a clear spot on the floor and just let it roam. That grin you get on your face watching it explore its world? That's completely normal, and it never gets old. Hit subscribe for next week's deep dive into adding Bluetooth control, and smash that like button so more future engineers can find this guide. And tell me in the comments, what's the first crazy mod you're planning to add? Until then, keep building, keep smiling, and remember, the only thing standing between you and a personal robot army is one lazy afternoon with an Arduino.